Dear viewers, welcome to another video on Lean Six Sigma tools using Minitab. In this video, we are going to understand about one of the very commonly used graphical representation tool called Run chart. So what is a Run chart? A Run chart is a line graph that shows data over a period of time. And using Run chart, we can identify whether the data is under the influence of any special cost variation or the data is only getting influenced by common cost variation. And how do we find this out? We find this out by observing is there any special non-random behavior or a non-random pattern is getting observed in the data. This is the technique by which Run chart identify presence of special costs. Let's get into this video and understand how does it work. As I was explaining, Run chart is a graphical tool which helps us to identify presence of non-random behavior. Now, what do we mean by random behavior and non-random behavior? As we know, every data will have variation, but that variation can be because of common cost variation and special cost variation. And what do we mean by that? Random behavior of variation is, for example, in this case, we are measuring weight of a tire. So in a tire manufacturing company, we are measuring the weight of a tire. So the weight of the tire is designed to be 10.6 kilograms. But not all tires will exactly be 10.6 kilograms. Definitely every tire, one after the other, will have some amount of variation. But how can that variation be random and non-random? If that variation is 10.6, 10.45, 10.72, 10.58, like that, if this variation is randomly changing, we call it a random behavior. But what is a non-random behavior? Let's say the first tire I make is 10.6 kilograms. The second tire is 10.65. The third tire is 10.7, 10.75, 10.8. What is happening here? The weight of the tire is varying, but it is not varying in a random way. It is varying in a non-random way. That means every next tire, the weight is getting increased. So that indicates that there is some kind of a special cost getting influenced where the data point is continuously in an increasing trend. Similarly, if the weight is continuously reducing for the every next tire that is getting produced, then also we can conclude that there is some kind of special cost because of which the data is continuously reducing. So this is what we mean by non-random behavior. So a Run chart is designed to observe non-random behaviors or patterns in a given set of data over a period of time. So a Run chart is basically a chronological chart, or in other words, you collect data with an agreed frequency of time and then plot the data in the same order of time. That's what we mean by a chronological chart or a time series chart. So if I decide to collect a particular data, I have to collect it with respect to time. I can collect it every hour, I can collect it every 2 hours, or I can collect it every 4 hours, or even I can collect it every day, but that frequency has to be fixed, and based on that I need to start collecting data. That's called drawing a chart over a period of time. Drawn over a time. That's what we mean by a chronological data. How do we decide this frequency? Should I collect the data every hour? Should I collect data every day? The frequency is decided based on how sensitive is your 6Ms towards time. So what do I mean by this word 6M? How frequently the skill of the manpower will get impacted because of fatigue, because of change in operator. Every hour, every 2 hours, every 3 hours, the skill of the operator might go for a change. You can pick up data for that frequency. If the machine goes through a wear and tear because of which machine vibration increases, heatness, all these increases, you can pick up that as a frequency. So depending upon how sensitive is your data towards, or how sensitive is your 6M towards time, based on that you can decide the frequency, and once you fix the frequency you can collect the data with respect to that frequency and plot this chart, and that's what we mean by Run chart. So now we will go ahead and understand how to construct a Run chart and how to observe different non-random behaviors that can exist in a particular data. So with respect to how to construct this chart, as I was explaining, this is a time series graph. So you need to collect data with respect to a agreed frequency of time. So what kind of data can be plotted in a Run chart? You can have your process Y as well as X metrics plotted in a Run chart. What do I mean by X and Y metric? Y metric is the characteristics of your output. For example, if you are making a tire, the diameter of the tire, the weight of the tire, these are all characteristics of your output. You can draw a Run chart for your output metrics like diameter, weight, which we call it as Y metric. We can also draw Run chart for input metrics like the weight of the raw material loaded into the mixture, the temperature of the oven in which heat treatment was happening, vibration level in the machine. So these are all process and input parameters, which we generally call it as X parameters or X metrics. For this also we can draw a run chart. So first step is to decide for what metric we are going to draw this run chart. And once you have decided that, the next one is to collect a good enough sample size. So the good enough sample size is generally we call 30 data points as a good enough meaningful sample size to observe any kind of a pattern. And once we collect this minimum sample size, then we need to plot the graph. So for a run chart, your x-axis will be the time series, which will be the horizontal line, the chronological order in which you have picked up the data, and y-axis will be the variable for which this metric is going to be, or this particular graph is going to be drawn. If the variable is weight, then the weight will be in your y-axis. If the variable is diameter will be in your y-axis. So x-axis is the time period for which the data is collected, and y-axis is the unit of variable for which this graph is getting drawn. So that is what you have in your x and y-axis. Step 4, you need to calculate the median of your data. So if you have collected 30 data points, you need to calculate the median of your data. So we all know how to calculate median. We can either use the Excel function median and select our data, or we can arrange the data in descending order and we can find the middlemost value. If you have 31 data points, your 16th data point will be your median. But if you have 30 data points, your 15 plus 16th data point divided by 2 will be your median. So in a run chart, the graph is drawn with respect to median of the data points for which we are drawing the graph. And finally, once you have plotted your x-axis, y-axis and median, then you will go ahead and start plotting your individual data points. And as you start plotting your individual data points, you can identify if at all there is any non-random behavior or non-random pattern is getting observed in your data. So what do we mean by this non-random behavior or non-random pattern? Let's see that. So here we have a sample of a run chart available. And in this particular example, we are going to discuss about a particular non-random behavior called mixture pattern. What do we mean by mixture pattern? Mixture pattern is where you will have lot of data points far away from your center line. For example, this is a case where I have collected the time to stitch a particular garment by a tailor in a garment company. So the tailor is stitching garment pieces. So I have collected data points with respect to time and I am plotting the data. And what happened is this tailor is stitching shirt as well as pant. So shirt takes less time, pant takes more time. But the person who went to collect data do not have this understanding that these two are two different time and we need to analyze it separately. So by mistake, what the data collector has done is the data collector consider every unit that is getting stitched as a transaction, and the data collector will start collecting data together where the data for stitching shirt and stitching pant got mixed up. As a result, what happened, you will find lot of data point far away below your center line, which are time to stitch shirts, and lot of data points far away from the center line above, which is time to stitch pants. So what happens, a presence of mixture pattern is an indication that two sets of subgroups got mixed up and we are trying to analyze the data together as a single subgroup. So when you see mixture presence in a data, you need to investigate and identify presence of two subgroup data getting mixed up, separate them and then do the analysis. And how do we interpret that in a Minitab run chart? In a Minitab run chart, if you see the run chart, if you perform a run chart in Minitab, you get p value. So there will be 4 p values. So if you see the mixture p value less than 0.05, you can conclude that that particular data have a mixture pattern present in it. So we need to separate two subgroups and then do the analysis. That is what we mean by mixture. The next pattern that we are going to understand in a run chart is what we call it as an oscillation pattern. What is an oscillation pattern? Due to some reason, the data points that we collect, every alternate data point is going above and below your center line. There is a toggling effect, or there is an effect of data point going above and below. So continuous fluctuation of data point is what we call it as oscillation. And when this data point is fluctuating above and below, that also tells you something about the process. The process is still not behaving in a a random way, there is, due to some reason, alternate transactions. One takes less time, another takes more time, or one is getting bigger, another one is getting smaller, one is getting heavier, another one is getting lighter, depending upon what metric you are trying to measure. And that also is a presence of a special cause. You cannot have every alternate data point going above and below your center line. If that happens, you need to conclude that there is a special cause in your process, and you need to investigate and identify what is that special cause. So that is about oscillation pattern. Third one is a cluster pattern. And if you see this particular graph, there is a consecutive data points which are getting very close to each other, and they are falling on the same side of the center line. And what does that tell you? This is a terminology which people generally say there is a shift in the process. What do we mean by there is a shift in the process? Shift in the process means there is something getting changed which is impacting the next 10, 15, 20 items that is getting produced. And that change could be in any of your 6 M's. That could be because of machine, that could be because of man, that could be because of the measuring instrument, that could be because of the machine, material, it could be of anything. But what is happening, the data points are almost getting performed at the same level on the same side of the center line, and this indicates there is a cluster that is getting formed. And this cluster formation is also a non-random behavior, and generally in a process which is getting only influenced by common cause variation, you will not be able to see a cluster getting formed when you try to draw a run chart. Again, how do you interpret whether the data have cluster effect or not? Look at the p-value of cluster, and if the p-value of the cluster is less than 0.05, you can conclude that there is a cluster formation that has happened in your data. Then the fourth pattern that we can see is the trend. So we all know the word trend means there is a particular pattern getting created, but the pattern here is, it could be consecutive data points continuously in the increasing direction, or consecutive data points continuously in the reducing direction. So this is what we call it as, there is a trend formation, or there is a trend pattern in the data. And again, how do you interpret whether there is a trend in my data or not? You can interpret that by looking at the p-value of the trend. If the p-value of the trend is less than 0.05, we can conclude that the data is under the influence of a non-random behavior. So let me once again summarize, friends. The non-random behaviors can be broadly 4 types. It could be, the first one that we saw is mixture, the second one that we saw is oscillation, the third one is cluster, and the fourth one is trend. So now what we will do is, we'll get into Minitab. I have some sample data, and we will see how this Minitab can be used to draw this run chart. As I was explaining in the beginning of the video, run chart can also be drawn in Excel or any other kind of format, but Minitab makes it easy for us to draw the run chart. So here I have Taylor 1. This, I'm going to draw the run chart. So to draw the run chart, you need to click at Stat, and then you need to click on Quality Tools, and in Quality Tools, the very first option is your run chart. And you can draw run chart for data points which are collected one after the other, and you can also draw run chart for data points which is collected in the form of subgroup. So I'll be explaining you all the types of run chart that we can draw. To start with, let me draw the run chart for Taylor 1. So Taylor 1 is my data. So let me select that. And I collected this data one after the other, so there is no subgroup. So I'm putting subgroup size as 1. And now I click OK. When I click OK, you get this particular run chart. And if you see, the interpretation of the run chart can be made very easy by looking at the p-values of the run chart. So here you can clearly see the p-value of the mixture is less than 0.05. Not only the p-value of mixture is less than 0.05, the p-value of oscillation is also less than 0.05. Why? Because you see lot of data points, alternative data points continuously going above and below your center line, and you also have data points far away from the center line. And let me repeat, friends, the center line in a run chart is a median, right? So here median is the center line. You see that as a dotted line, and you see the data points going above and below. Maybe those who are familiar with control chart, along with the center line, there will be upper and lower control limit in your control chart, but in a run chart, we do not have a control limit. We only understand the non-random behavior by the data point, where does it getting positioned with respect to center line. We are not going to understand based on any control limits above and below. There is no control limit. So in a run chart, there is only a horizontal line, which is the median of your given data point. So here we can conclude that this data have both mixture as well as oscillation effect. Now let me draw this run chart for another data, which is Taylor 3. So in Minitab, when we press Control E, it will take us to the previous screen. So here I'm going to select a Taylor 3 and the subgroup size will be 1. And now I can click OK. And when I click OK, I get the control chart for Taylor 3. And here if you see, there are a lot of data points that is getting clustered on the same side of the center line. And as these data points are getting clustered on the same side of the center line, it is an indication that there is a process shift. And what do we mean by process shift? The process is temporarily getting shifted to a new level of operation. That is called, what we call it as a shift. That shift can be good or bad for the process depending upon which side you find this cluster, right? So time is lower the better. So if there is a process shift, this shift is actually good, but we need to investigate and understand how did we able to achieve this shift. Is it because of skilled resource operating at that time, or is it because of a better raw material that we received? Depending upon any of those 6 M's, there could be a shift, and this shift is good for the process or bad for the process, depends on which side of the center line you get this cluster formation, and based on that you can make a decision, you can do investigation. If it is a good to have special cause, you can make it permanent in your process. If it is a not good special cause, you need to see how it can be eliminated. So all those things are subsequent exercises, but at this point of time the Gantt chart is highlighting there is a shift in the process. And how we can conclude that? If you see that cluster p value, it is less than 0.05. so similarly, let me close this graph and let me press Ctrl E and I draw the control chart for Taylor 4 data. And if you see this Taylor 4 data, if you maximize the graph, you will find that the data points are continuously on an increasing trend, or here there is one data point which is breaking the trend. Otherwise here also you would have seen continuously data point in the reducing trend. And what does this tells? This tells again there is a kind of a special cause getting influenced in the process. There is a non-random behavior, and we need to understand what is that non-random behavior, and we need to see what is the special cause which is creating the non-random behavior. Again, the p-value is less than 0.05. So this is how we draw Gantt chart if we collect data one after the other. But if we collect data in the form of subgroup, what do we mean by collecting data in the form of subgroup? Here in my column C5, I have collected the weight of tire, and I have collected this data every hour 10 data points. So that means I am collecting my sample not one after the other. Instead, I am collecting my samples in the form of subgroup. What is the definition of subgroup here? The definition of subgroup is every hour. And what is the subgroup size? The subgroup size is 10, because every hour I am collecting weight of 10 tires. So every hour is my subgroup, 10 is my subgroup size. Now what I do, I click on stats, I click on quality tools, and then I click on Gantt chart. This time I select weight because this is the data for which I want to draw the Gantt chart. I enter subgroup size as 10. After entering subgroup size as 10, I have two options. I can select plot subgroup means, or I can select plot subgroup medians. To start with, I'm going to keep the mouse or I'm going to keep the option as plot subgroup medians. I will explain what will happen if we choose plot subgroup means also, but I'm going to select plot subgroup medians. Now when I click OK, you get this kind of a chart. And what does this chart tells us? Here the gray color dots that you see here are individual values for the first 10 data points. Why first 10 data points? Because we declared here the subgroup is every 10 data point. So this is my first subgroup, and for that first subgroup, this blue color dot is the median. For those 10 data points, this is the median. So I get the median of the subgroup, and the median of the subgroup is getting plotted here as a trend chart. And for those individual medians of the subgroup, then another median is getting calculated, which is the grand median, and that median becomes your center line. And based on this Gantt chart is getting published. Let me repeat, friends, when you draw Gantt chart for data collected in the form of subgroup, you can first calculate the median of the subgroup. For every 10 data point, there's a median. That's the blue graph. And based on the trend of this blue graph with respect to the median of these individual medians, the chart is getting drawn and your p-values are getting calculated. So this is one option that you can do. The other option that you can do is, instead of plotting this graph for the medians of the subgroup, I can plot this graph for the means of the subgroup. So I can click on this and I can say OK. Now what will happen? For the same 10 data points, you will have the mean calculated. So what you see now as a blue dot is the mean of the individual gray color dots, which is nothing but the individual data point. So the mean is getting plotted, and that mean is getting plotted as a trend line. And then for those individual means, again median. So the center line is always median. Whether you wanted to calculate subgroup means or subgroup medians, that's fine. But after calculating subgroup means or subgroup medians, when you try to plot it in the graph, the center line will be the median of those subgroup means or subgroup medians. So the center line will be the median of the subgroups. In this particular example, the blue dots are nothing but means of your subgroup. And if you see, if you decide to go for median, you will find that the data do not have a special cost. But if you decide to go for mean, the data will have a special cost. Why? Because in each of the subgroup there is a possibility of an outlier. For example, in this subgroup this is an outlier, in this particular subgroup this is an outlier. So the impact of outlier will be there on your mean if you try to calculate subgroup mean. So that's why when I draw a Venn chart for subgroup data, generally I prefer drawing this with subgroup medians for two reasons. Why? When there is a special cause or an outlier within the subgroup data, then median becomes a better measure of central tendency. Or in other case, if there is no outlier, still mean and median are going to be very close to each other. So there is nothing wrong in choosing medians and then drawing your Venn chart for data collected in the form of a subgroup. So friends, I hope you understood how to draw Venn chart for data collected individually and how to draw Venn chart for data collected in the form of subgroups. And once you draw these Venn charts, how to interpret the results of the Venn chart and identify whether your data have any presence of non-random behaviors such as cluster, mixture, trend or oscillation. So if there is any such presence of non-random behavior, that can be identified by looking at the p-value for each of those non-random behaviors. So if you see here, there are individual p-values. That is why in Minitab it becomes easy for us to make decision, because the decision is made with the help of a statistical calculation here. Not only you can or not you make decision by looking at the graph, but you can also look at the summarized value of the p-value of each of those individual clusters, right? So friends, so a quick summary: Venn chart is a time series graph drawn by data collected in a chronological order, and the purpose of we using this chart is to identify the presence of a non-random behavior in your data. So by non-random behavior we mean presence of cluster, mixture, trend or oscillation. If any of this non-random behavior present in your data, you can conclude that your data is under the influence of special cause. You can do further investigation and identify what is that special cause. Is it a good to have special cause or it's a bad to have special cause? Is it a controllable special cause or non-controllable special cause? And based on that you can take actions. If there is no such non-random behavior and all the p-values are greater than 0.05, then you can conclude that your data is under the influence of only common cause variation and there is no influence of special cause variation. I hope this video was useful for you to understand how to draw Venn chart, how to interpret results of Venn chart, what is the logic of Venn chart. Thank you for your time. Thank you for listening to this video. For more such videos on tools and techniques of Lean Six Sigma and how to perform these tools in Minitab, please subscribe to our channel. See you in another video. Thank you very much.